Okay, so today we're going to go over the last component in Chapter 7, which is double and half angle identities. The nice thing about double and half angle identities is they're the exact same as our sum and difference, except we're using different identities. So instead of using our sum and difference identities, we're using our double and half angle identities. So we're just using different formulas, but the concepts are very, very similar. So in this first problem here, it says, if sine of theta equals 3/4 and has a terminal side in quadrant 2. So that means if I were to draw a triangle, my triangle is in quadrant 2. Sine is 3/4, so y is 3, r is 4, and I'm going to have to use Pythagorean theorem to find x. So 3 squared plus x squared equals 4 squared. That's going to give us x squared is 7. So x is the square root of 7, but it's negative because we're in quadrant 2. Okay, so here's theta. So if I want to find sine of 2 theta, I'm going to look in here, and I'm going to find which identity I'm going to use. Well, sine of 2 theta is equal to 2 sine x cosine x. So this is equal to 2 cosine theta sine theta. So if I look here, sine of theta is equal to 3/4. Cosine of theta is equal to -√7/4. So if I plug those in here, I've got 2 times cosine, which is -√7/4, times sine, which is 3/4. Now remember, I can make anything over 1, so now I can multiply. 2 times -√7 times 3 is going to give us -6√7 over 1 times 4 gives us 16. And then we can simplify. This can divide by 2, this can divide by 2, so we've got -3√7/8 as our final answer. Okay, so then same thing, if I look at cosine of 2 theta, now if we look at cosine of 2 theta, we've got cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. My favorite one to use is the first one. I tend to think that that one's the easiest to use. Sine and cosine already have denominators. If we use the ones with ones, we're going to have to get common denominators, and that's not as easy. So my suggestion is to use the top one here. So that tells us it was cosine squared minus sine squared. So that's saying to take cosine and square it, and then to take sine and square it. So cosine we said was -√7/4, and sine is 3/4. And remember, when we square fractions, we square the top and the bottom. So -√7 squared just gives us +7, and 4 squared gives us 16. 3 squared gives us 9, 4 squared gives us 16. Now that we've squared, we can subtract. 7 minus 9 would be -2. And then simplify, -1/8. Okay. Number 3, tangent of 2x. So our tangent formula is 2 tangent over 1 minus tangent squared. So I'm going to copy that down just from my sheet. Remember, you get to use this sheet on your test. You do not have to memorize these. So let's look back at our thing. So we know that sine of theta is 3/4. We know cosine of theta is -√7/4. And tangent of theta would be y over x, which would be 3 over -√7. So I'm going to leave it like that and rationalize later. So I'm just going to leave this as 3 over -√7, and I'm going to plug that in. So we got 2 times 3 over -√7 over 1 minus 3 over -√7 squared. So let's do some math here. So we've got, this is like 2 over 1, so that's going to give us 6 over -√7. On the bottom here, I have 1 minus 3 squared gives me 9. √7 squared is 7. So the reason I left it is for this piece. When you end up squaring it anyways, the root goes away, and then if you guys rationalize this, you would have had 3 root 7 over 7, and when you square that, you always mess up. So I would suggest just leaving it, square it. This is easy to rationalize, but squaring a rationalized number, people tend to mess up. So I'm going to rationalize the top now, so that gives me negative 6 root 7 over 7. And then on the bottom, I've got 1 minus 9 over 7, so if I made that 1 7 over 7 so that we have common denominators, I have 7 minus 9, which would be negative 2 over 7. Well, remember, if I have a 7 here and a 7 here, those can cancel. I have a negative divided by a negative, which is going to give me a positive 6 root 7 over 2. And then the 6 and the 2 can also simplify, giving us our final answer of 3 root 7. All right, now we've got sine of theta over 2. So if we look at our formula here for sine of theta over 2, we have sine of x over 2, theta over 2. They mean the same thing. Remember, x and theta are the same. We've got plus or minus the square root of 1 minus cosine over 2. So I'm going to start by writing that down. Now the plus or minus is not telling us that the answer is plus and it's minus. It's that you have to choose. So this is something you choose. Is it plus or is it negative? So if we remember, this told us it was in quadrant 2. So if we're in quadrant 2, that means that theta is in between pi over 2 and pi. Right, if we're in quadrant 2, we're between pi over 2 and pi. However, if this is theta over 2, if you remember back to when we changed our domain in the last problems, if this is theta over 2, then that really makes this pi over 2 and pi over 4. So if this is theta over 2, we're between pi over 4 and pi over 2. Well, pi over 4 is right here, and pi over 2 is right here. So we're between here, which means we're in quadrant 1. So we have to ask ourselves, is sine positive or negative in quadrant 1 in this case? Sometimes it might be quadrant 2, sometimes it might be quadrant 3. It all depends on what's going on here. And this, remember, came from because the problem told us it was in quadrant 2, but then when I divide each thing by 2, we end up in quadrant 1. Well, sine is positive in quadrant 1, so in this problem, I'm choosing the positive symbol. So I have positive 1 minus cosine, and we said that cosine was negative root 7 over 4. So 1 minus negative root 7 over 4 all over 2. When we subtract a negative, that really means addition. We have 1 plus root 7 over 4. We'll want to change that 1 to be 4 over 4. So we have 4 plus root 7 over 4. All over 4, all over 2. Well, if we're dividing by 2, remember that really just means we're multiplying by a half. So that gives us 4 plus root 7 all over 4 times 1/2, which gives us 4 plus root 7 over 8. And we're going to leave our answer just like that. Let's look at cosine of theta over 2. So we've already decided that theta over 2 was between pi over 2 and pi over 4. We've already decided that, which means it's in quadrant 1. So if we look at our formula, we have cosine of x over 2 equals plus or minus 1 plus cosine over 2. So we have plus or minus 1 plus cosine theta instead of minus like we did in the last problem, all over 2. Well, because this is quadrant 1, that tells us I'm going to pick the positive. So we've got positive square root 1 plus cosine all over 2. So let's make this one a 4 over 4. So that gives us 4 minus root 7 over 4 all over 2. Remember that that means multiplying by a half, which gives us 4 minus root 7 all over 8. Tangent of theta over 2, so if we look at our sheet and we copy it down, tangent of theta over 2 is 1 minus cosine theta over sine theta. No plus or minus to choose from in this problem. We know that cosine is negative root 7 over 4, and we know that sine is 3 over 4. Subtracting a negative means addition. Let's make this 1 a 4 over 4, so we can have some common denominators. So we have 4 plus root 7 over 4 over 3 over 4. Well, once again, these 4's can cancel because they're both on the bottom. So that gives us 4 plus root 7 all over 3. Okay, I'm going to kind of skip a little bit here. I'm going to skip this page. I'm going to do this in the part 2 video. But I want to do this top one real quick for this part 1 video. So I'm on number 12. So it says use the picture on the right to find cosine of 2 theta and tangent of a half theta. So it tells us that we have this circle x squared plus y squared equals 169. And then here's our point x comma negative 12. Well, let's take a picture. Let's figure out what this circle is telling us. Well, remember that x squared plus y squared equals r squared. So that's telling us that r squared equals 169, which means r is 13. So if I were to make this a triangle like we have in the past, we know right here that r is 13 because r squared is 169. Now we also know that this is x comma negative 12. Well, remember it's always x comma y, so that's telling us y is negative 12. So here's our y, negative 12. Now once we know r and x, y and r, I can find x using Pythagorean theorem. So x squared plus 12 squared equals 13 squared. And we end up with x is 5 using math, right? Using our Pythagorean theorem. So 5, 12, 13. So now that we have our triangle here, we know that sine of theta is going to be negative 12 over 13. Cosine of theta is going to be 5 over 13. And tangent of theta, oops, you guys can't see this. Tangent of theta is going to be y over x, so negative 12 over 5. So now that we know all of this, now we can do the same thing that we were doing earlier, right? Cosine of 2 theta is cosine squared minus sine squared. So we would plug in 5 over 13 squared minus negative 12 over 13 squared. Finish that problem on your own. Tangent of 1/2 theta, our formula is 1 minus cosine theta over sine theta. Plug in our numbers. 1 minus 5 over 13 over negative 12 over 13. Okay, finish this problem, check your answers. I just wanted to show you how this is a fancy way of saying set up a triangle and solve. So I want you guys to solve these and then check your answers online and then move on to the second video.